Today's lesson is going to be about areas and distance. Okay, so what that means is when we're given a function, we want to find the total area underneath its curve between the equation and the x-axis. So let's take a look at a problem here. Okay, so we're given f of x equals x squared plus 1 on the interval from 0 to 2. Okay, so what I like to do first is I like to draw it. So I drew it here. So this is what the equation looks like on that interval from 0 to 2. Okay, so to find the area of the curve, we can't exactly find the exact amount, but we can find estimates. Okay, so to do an estimate, we can take this equation here of delta x equals b minus a over n, and b is significant, and b represents the rightmost endpoint, which is 2, and a is the leftmost endpoint, which is 0, and n is how many intervals we divide this region up into to get an estimate of that area. So let's divide this region into 4 parts. Okay, so we've done that there. So now this picture is a little bit small, so I went ahead and went on a bigger and drew it bigger so we could all see. Okay, so this is the bigger view of that equation there. Okay, so to find an estimated area, we're going to take the right endpoints. And to do that, we got this endpoint here. There's 1, 2, 3, and 4. Okay, so now to take the area of this region here and here, what you want to do is you want to take your delta x, which was b minus a all over n, and we want to divide this, and we divided this thing into 4 parts. Okay, so our delta x is going to be 2 minus 0 over 4, so that equals 1/2. So delta x is our 1/2. So now what we want to do is we want to take each value that we have here. So this is 1/2, this is 1, this is 1.5, and this is 2. Okay, so by doing that, we then want to take the equation of delta x times f of our right endpoints, which are f of 2 plus f of 1.5 plus f of 1 plus f of 0.5, which is 1/2. Okay, so to do that, we have this here. Okay, so that's how we find the area with our right endpoints. Okay, so now plugging in everything here, we get 1/2 times this here, this all right here, f of 2 plus f of 1.5 plus f of 1 plus f of 0.5. And to get f of 2, we plug 2 back into our equation here. So we get f of x equals x squared plus 1. So we plug 2 into there and all of our other points as well. So when you plug in these points, 2, 1.5, 1, and 0.5, into the formula here, x squared plus 1, you just plug it in and you end up getting, so f of 2 is 5, so then plus f of 1.5, you could also say is 3/2, so 3/2 squared plus 1, that would be 13/4, plus f of 1, so 1 squared plus 1 is just 2, plus 0.5, which is just 1/2, so 1/2 squared is 1/4, plus 1, that equals 5/4. Okay, so now with this here, you have your delta x and your all the points here added up to get a further area that you can estimate. Okay, so now carrying this out further, you will get, so by adding all of these up here on the inside, you end up getting 1/2 times 23 halves. So then multiplying these together, your answer will be 23 over 4. So this is your approximated area using your right endpoints. Another way you can solve this problem is by taking the area using the left endpoints as here, 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 and here. Okay, so I went ahead and kind of did it already. So I did, because all it is just, instead of using the right endpoints, you just use the left. So basically you use the same delta x, and then you use the left endpoints. So then using the left endpoints, you get 1/2 equals f of 0 1/2 times f of 0 plus f of 1/2 plus f of 1 plus f of 3/2. Okay, so doing that, you then end up getting 1/2 times 0 squared plus 1 in parentheses plus 1/2 squared plus 1, and then plus 1 squared plus 1, then plus 3/2 squared plus 1. So then all of that equals 1/2 times 1 plus 5/4 plus 2 plus 13/4. And then you get 1/2 times 15/2. And then your final area for using the left endpoints here, you end up getting an answer of 15/4. The third way you can solve trying to find the area using your estimates, there's also what you know as midpoint. So when you use the midpoint, you just take the points in between the right and the left that you would use. So in this case, it's you would use for the midpoint 1/4, 3/4, 5/4, and 7/4 to get your midpoint values. So to do that, you to calculate the area, you just use your same delta x. Your delta x is the same, so it's 1/2, and then you put 1/2 times your f of 1/4 plus f of 3/4 plus f of 5/4 plus f of 7/4. Okay, so doing all that, I calculated it. So it would be 1/2 times 17/16 plus 25/16 plus 41/16 plus 65/16. Okay, so next it'll be 1/2 times 37/4, which then you get an answer of 37/8. So that is your area using your midpoint values. So to conclude, our estimates for this area here, the shaded region in pink, using our left endpoints, we got an estimated area of 15/4. Using our right endpoints, we got 23/4. And then using our midpoint values, we ended up getting an estimated area of 37/8. So all of these are estimates, but using their left endpoints is an underestimate. Using your right points is an overestimate, and your midpoint values may or may not be close to what it actually is, but it is still an estimate. Okay, so for this problem, it gives us a table of values, and then it gives us here of what this table represents on a graph. Okay, so this problem is asking us, given the values for f of x on the table above, estimate the area under the graph of f of x from x equals -5 to x equals 5 using left endpoints of 4 sub-intervals. And then, okay, so part A wants the area using your left endpoints. Okay, so to do that, you gotta take your delta x times your f of whatever that left endpoint is. So in this case, your left endpoints are -5, -3, 0, and 1. But a common mistake people might make is because it asks for 4 subintervals, they might just take 5 minus a negative 5 all over 4, but that is incorrect because each distance between these x values is all different. So you just take the distance between the 2 points. Okay, so that looks like this. Okay, so in this case, it would be 2 times 10 because distance between these 2 points is 2, and you want to take the left endpoint, so that's 10. Okay, so next, it would just be 3 times 7 plus 1 times 5 plus 4 times 8 because of these distances here, here, and here. And you want to take the left endpoints, so that's 7, 5, and 8, which is here, there, and there. Okay, so calculating that out, it would be 20 plus 21 plus 5 plus 32. And so adding all that up, you get an answer of 78. Okay, so those are your left endpoints. So now your right endpoints here, you just do the same thing and use the same delta x, except you use the delta x between your right endpoints. So your right endpoints would be 5, 1, 0, and negative 3. Okay, so that looks like this. Okay, so 2 times 7 plus 3 times 5 plus 1 times 8 plus 4 times 11, because the distance between these 2 points here is 4, there, and the right endpoint is 11. And you do the same thing for these here, right here. Okay, so you do the same thing. The distance between the negative 3 and 5 is 2, and you want to use the right endpoint, so that's 7. And you do the same thing for here, for your second right endpoint here, and then your third right endpoint, which is that. Okay, so you use those, you plug those in, and then you end up getting 14 plus 15 plus 8 plus 44, and your answer is 81. So your area using your right endpoints for this problem is 81.